VLSos here. This is a video lesson on rational transformations. We're going to talk about what a transformation of a rational function is and practice it by starting with the problem graph g of x if g of x is defined as the rational function x plus 2 over x minus 1. And the manner in which we're going to graph it is as a transformation of 1 over x, which means we're not going to grab graphing software, punch in the keys, and look at what we got and then sketch what's on the screen. We're going to consider that this function is a transformation of the parent hyperbola 1 over x, and then use what we know of transformations in order to graph it by hand. The reason why we would do this is not just to be able to produce the graph, but to gain confidence that we can do problems that seem very sophisticated without technology, and we can do them without guess and check. We're also going to review a very good algebra technique. So our concern now is thinking of this equation in the form of a transformation of 1 over x, which means that I'm looking for, or I'm looking to convert this rational function into this form. Why this form? Because the parameters a, h, and k then inform us of the individual transformations, which we can do by hand if we have the parent graph to start with. So this form here is a transformation of 1 over x, where a would be a dilation, h would be a horizontal translation, and k is the vertical translation. So how do I convert x plus 2 over x minus 1 into this form so I can then read and describe those transformations with some algebra? I am going to get x out of the numerator so that I can put it in the form of something over x in the denominator if I'm able to manipulate the numerator so that it equals the denominator. In other words, I want there to be an x minus 1 in the numerator. And that's easy to do if I include a subtraction of 1 and then put the plus 3 over here. It's as if I've broken up the 2 to supply what I need for this negative 1, but of course I still have in the numerator that which is equal to what I started. And I'm still showing this over x minus 1. Why would I do that? Because I can break this up now into the x minus 1 over itself and the 3 that is still being divided by x minus 1. I've done that because this portion can now turn into an integer, 1. I'm going to list this first term that includes x, 3x minus 1, and then the simplified integer, something over itself, is 1. I've done it. I've turned it into 1 over x that's being transformed in 3 different ways. And I can list those ways here. This is the equation equal to y. So here I have in graphing form. But if I'm going to list my transformations, I'm in the habit of grouping the transformations with the variable that they affect. So I'm going to subtract 1 from both sides and then divide by 3. So I get y minus 1 divided by 3 is equal to 1 over x minus 1. Why would I do that? Because in this form, I can see the transformations and then list them descriptively and use the description to then graph by hand. What does taking 1 away from the vertical variable do? We think going down, but it's counterintuitive. We're going to go up by 1. What does taking 1 away from the horizontal variable do? It's subtraction, so we think to the left, but it's counterintuitive. We're going to go right by 1. What does dividing the vertical variable do? It's a dilation. We think division diminishes, but it's counterintuitive. We are going to triple vertical distances, or we're going to vertically stretch it by a factor of 3. Now, guided by these descriptions, we're ready to graph by hand. These descriptions are transformations of the parent function 1 over x. So I'm going to sketch lightly what parent hyperbola looks like to guide how I'm going to transform it. Parent hyperbola has 2 branches like this. There's some symmetry here. The asymptotes are the axes. So if I go up 1 and right 1, I could imagine those asymptotes moving to new positions. I'm going to draw the asymptotes of my transform function. Up 1 will be the horizontal asymptote moved up 1, and right 1 will be the vertical asymptote moved to the right 1. These are the locations of the new asymptotes of the transformed graph, and they take care of the up 1, right 1. Now, a vertical stretch of factor 3 means that vertical distances are going to elongate. So the graph is going to look stretched out vertically. And we'll be able to see that stretching out vertically a little more readily on the bottom. I'm going to erase the parent function to get a clear presentation of the transformed function. A shifted and vertically stretched out hyperbola. Imagine being asked to graph something like that by hand. Many people, I think, would begin by a t-table and choosing values of x and calculating complicated values of y, and having to do several of them in order to get enough points to guide these curves. But you can do it with algebra and then think of it as a transformation that's described.